Hello and welcome guys to my YouTube channel. In this video, we will be covering upper and lower bound. So let's start by explaining what is the upper and lower bound. Let's say you had a bunch of boxes. Okay, box 1, 2, 3, 4. And these boxes, they had a slightly different weight. Okay, so you got a student to measure the weight of each of those boxes. So the first box, for example, the student got 10.4 kilograms, and the second student, he got 9.6 kilograms, and the third one, he got 10.49 kilograms. On the last student, he got 9.9 kilograms. Now, let's say you asked that the students must submit the weight to the nearest whole number. Okay. Now, if every student submits his weight, every single student will submit 10 kilogram. Because this rounds to 10, nearest whole number, and this rounds to 10, and this rounds to 10, and this as well rounds to 10. So you have 4 different weights that are in reality kind of different, slightly vary. However, to the nearest whole number, they're all the same. Okay. And so if I go ahead and give this figure to somebody else, somebody who doesn't know what the original weights were, so I was like, hey, every single box weighed 10 kilogram to the nearest whole number, this person should know that just because they weigh 10 kilogram to the nearest whole number doesn't mean they actually weigh perfectly 10. They can technically be 9.5 or above, but also at the same time, they are less than 10.5. All the numbers between 9.5 and 10.5 without the 10.5 itself all round up to 10 when you round them to the nearest whole number. So we're talking here 9.6, 9.7, 0.8, 0.9, even 0.85, for example. It doesn't matter. This is the number that matters here, but this is also a possibility. And the same thing here, 10.1, 10.2, and so on, but not 10.5, okay? 10.5 is not included because 10.5 would round up to 11 kilograms. So it's definitely not a possibility, okay? So I could say that if the weight was W, then it's definitely greater than or equal to 9.5, and it is less than 10.5 without including the 10.5 itself. And this is what we call the error interval. Okay, so any kind of measurement you give me with the unit of round, okay, has an error interval where the actual value could lie between 9.5 and 10.5. I don't know which exactly. Now, also, let me change the color. This right here, the 9.5, this is what we call the lower bound, which is the lowest possibility, okay? And this right here, this is the upper bound. And of course, like I said, there is no equal here, because if there was, then that means the 10.5 is included. And if the 10.5 is included, then it would round up to 11, so we don't want that. Okay, so this is what the upper and lower bound is, and this is what the error interval is. Now, let's move to like the rule for finding the upper and lower bound. So firstly, you have the upper bound, which is the original number plus the error, and the lower bound is the original minus the error. Now, how would we find the error? It's the unit of round divided by 2. This will get more clear with examples, But for now, this is not really to memorize. You know, with time, you'll just understand how it works. Okay. Let's look at this example. A number x is rounded to 1 decimal place. The result is 5.6. So firstly, this is the unit of round basically, and the result is 5.6. Using inequalities, show the range of possible values of x. Okay. So when he's asking me to show the range of possible values of x using inequalities, he's asking about what are the possibilities of x before it got rounded. So we basically want to find the error interval. Okay. So now we know that the unit of round. So firstly, the original number it's 5.6. Okay, so this is the original. And this right here, 1 decimal place, is the unit of round. Now we need to change the 1 decimal place to an actual number. So how do we do that? Firstly, you need to write the 5.6 down, okay? And focus well here. So we know that it got rounded to 1 decimal place, okay? You go and look for where is the 1 decimal place in this number. The 1 decimal place is right here, okay? So you replace that with a 1, and everything else gets replaced with a 0. So the point stays where it is, and this becomes 0, okay? So see this right here, 0.1. This is the unit of round, basically. Okay, so we've found the unit of round. Now in order to find the error, it's going to be the unit of round divided by 2, and this gives us 0.05. Okay, so now I can go ahead and say that the upper bound is basically the original number, which is 5.6 plus 0.05, and that gives me 5.65. And the lower bound, I'm just going to write LB for lower bound, is basically 5.6 minus 0.05, which gives us 5.55. Okay, so what is the range of possible values of x, or the error interval? I would say that x is basically between, it's greater than or equal to 5.55, and it is less than 5.65. Okay, this is the answer right here. And when you think about it, all the numbers in this interval would round up to 5.6. Okay, I hope this was clear. Let's move on to some examples. Okay, so a number x is rounded to the nearest 2 decimal places to give 7.88. Find the upper bound. B, find the lower bound. And C, state the error interval of x. Okay, so let's go ahead and start with A. Now, so here's the thing. So again, so I write the number down, okay, and we know that from the question that 2 decimal places. So I go ahead and we look for the second decimal place. So where's the second decimal place? This is the first, this is the second. So we go ahead and put a 1 below the second decimal place and turn everything else into zeros. So this is 0, this is a point, and this is 0. So it's 0.01. This is my unit of round, okay? And now I want to find the error. So I divide it by 2. We get 0.005. And this right here, this is my error, okay? So now in order to find the upper bound, UB, it's equal to 7.88. I miswrote this. Yes, plus 0.05, and this gives us 7.885. And the lower bound is 7.88 minus 0.05, and it gives us Sorry, but this is part B, so I'm gonna go ahead. I'm just gonna write part B right here. So the stop part is part A, and now we're dealing with part B. So obviously, for finding the lower bound, it's gonna be the same error, so we just subtract it. And I will fix this right here. 0, 5, and so we get 7.875. Okay, you don't have to do those calculations mentally. You can just go ahead and plug them on the calculator, and they will give you the answer anyways. But I do want to say here that, so right here, this, dividing it by 2, you can do it by the calculator, or you can do it in like a quick smart method, okay? And the way it works is as follows. Let me just show you. So basically count the number of zeros right here, and they need to be more than that by 1, okay? So right now we have 1 0. So we're gonna make it 1 and then another 0, and just put 5 right here. So basically, look, just replace the 1 by a 0 and a 5. Makes sense? So if I told you 0.01 divide by 2, this would be 0.00. Replace the 1 by a 0 and a 5. Okay, this is the answer. Okay, so this is a simple trick to do it quickly, or you can do it like at the calculator. It's fine. Okay, let me just erase this now. So for part C, we're being asked for the error interval of x. So x is basically in between, and we have the lower bound over here, 7.875, and the upper bound over here, 885. Okay, moving on. All right. Given that v is equal to 14, correct to 2 significant figures, u is equal to 8.4, correct to 2 significant figures, x is equal to 4.5, correct to 1 decimal place. Find A, the upper bound of v. Okay, so you write A right here. And let's see. Let's take a look at my number. So v, it's 14, and it's rounded to 2 significant figures. Okay, so this is really important. So I'm going to go ahead and firstly count the significant figures. So firstly, this right here, this is the first significant figure. And this right here, this is the second. So like we said, we replace the second significant with 1, okay, because it's rounded to 2 significant figures. And everything else becomes 0. So now let's talk about this. So the 1 is supposed to become a 0, but 0 on the left right here, does it actually make any difference? No. You see, the number is still 1, okay? So we just keep it as 1. And now we're going to divide it by 2, and that gives us 0.5. And this right here, this is our error. Okay? So now I'm going to go ahead and write down the upper bound. So UB is equal to 14, the original number, plus 0.5, and this gives us 14.5. This right here is the upper bound. Okay, done with part A. Let's take a look at B. The lower bound of U. Now, U is 8.4. Also rounded to 2 significant figures. Let's start counting significant figures. We need to stop at the second one, okay? Because this is 2 significant right here. So this is the first. We count from the left to the right. This is the first, and this is the second. So we replace the second one by 1, and we replace everything by 0. So point, and this is 0 right here. You can't not put this 0. 0 makes a difference, okay? So 0.1, this is my unit of round, and I will divide that by 2, and we get 0. Like I said, replace the 1 by 0 and a 5, okay? And this right here is my error. So notice something. The error for this number, for u, is different than for v, even though they're both rounded to significant figures. But because significant figures are relative to the number, so they depend on what the number is. So in turn, your error will be different in a lot of cases, okay? So that's why you should always follow the method of just finding the second significant figure, replacing it by 1, and turn everything into 0. This will always put you in the right position to find the correct error. And now I'm going to find the lower bound by subtracting. So we're going to write 8.4, this is the original, minus 0.05, and we should get 8.35. This is the lower bound. Okay, so for part C, we're being asked to find the range of possible values of x. Now, so we know that x is 4.5, rounded to correct to one decimal place. Okay, so where's the first decimal place? It's this right here. So I'm just going to replace that by a 1, and everything else turns into a 0. This is my unit of round. I will divide it by 2 and find that the error is 0.05. Okay. And now, so to find the range of possible values of x, basically we want the error interval. In order to find the error interval, we want to find the upper bound and the lower bound. I'm going to go ahead and find the upper bound, which is 4.5 plus 0.05, which is equal to 4.55. And the lower bound is 4.5 minus 0.05, which is equal to 4.45. And so the error interval, or the range of possible values, is basically between the lower bound, which is 4.45, and less than 4.55. This is the final answer right here. I hope it was clear. Okay, now let's move on to the next example. Okay. Now, a number n is rounded to the nearest 10 to give 450. Find the upper bound. Okay. So again, so overall in this question, by the way, they want the upper bound, the lower bound, and the error interval of n. Okay. So I'm gonna go ahead and find it. So we have firstly the 450. Okay. And so we know that it got rounded to the nearest 10, right? Now, where are the 10? It's right here. So this is the ones, those are the tens, this is the hundreds. So the tens, we're going to place them by 1, and everything else gets replaced by a 0. So this is already a 0, so it's a 0. And there's a 0 here. But again, like we said, there's no need for the zeros on the left. They don't make a difference. This number is still 10. Now, notice something. So the 10 is exactly the same thing as here, and that's the thing. So it's being rounded to the nearest 10, to the nearest 100, to the nearest 1000. You're basically already being given the unit of round as a number. So you can just use it from the question or follow the normal method. Both are fine. So now we're going to divide this by 2, and it gives us 5, and this is the error. And so in order to find the upper bound, I'm going to go ahead and write upper bound is equal to, we're going to add the original plus the error, which is 5, and we get 455. That's for part A. Part B, finding the lower bound will be just simply subtracting. So 450, the original, minus the error, 5, and gives us 445. And finally, state the error interval. The error interval is basically between n, is going to be between the upper bound 455 and the lower bound 445. Okay, don't forget your equal right here. There is an equal here, there isn't an equal here. Okay, we explained why this is the case earlier. This looks like an equal. I'm going to delete this. Okay, moving on to the next example. All right, given that x is equal to 1.5 to the nearest one decimal place, y is equal to 2500 to the nearest 100, and v is equal to 14.5 to the nearest 3 significant figures. Firstly, we're being asked to find the lower bound of x. All right, so So firstly, I'm going to grab x, write it down, 1.5, and we know that it's being rounded to it's been rounded to the nearest one decimal place. So we're going to go and look for the first decimal place, and it's the 5 right here, and we're going to replace it by 1, and everything else turns into 0, so 0.0. So 0.1, this is the unit of round. Divided by 2 gives us 0.05, and this right here is the error. And so the lower bound is equal to 1.5 minus 0.05. We get 1.45. Okay. Part B. We want the upper bound of y. Now let's write y down. So y is equal to 2,500. Now, like I've said before, we know that it got rounded to the nearest 100. This 100, it's the unit of round. So you can just write it down. And it's basically as if you found the hundreds, replaced them by 1, and turned everything else into zeros. And now I'm going to divide this by 2, which is 50. And this right here is the error. All right. So in order to find the upper bound, it's basically going to be 2,500 plus 50. And it gives us 2,550. Okay. That's it. This is the answer. And I forgot to box this answer as well. Okay, finally, C. So in C, we're being asked to find the error interval of V. Finding the error interval means you have to find the upper bound and the lower bound. So let's write down V. So V is equal to 14.5. And this is rounded to the nearest 3 significant figures, okay? So basically, nearest 3 significant figures. Let's count. We want the third one. This is the first, this is the second, and this is the third. So again, we're going to replace that by 1, and everything else by a 0. So the 4 became a 0. There's no need to put another 0 here. It wouldn't make a difference. So just 0.1. And divide that by 2, and we get 0.05. And this right here is my error. So the upper bound and the lower bound. So you have the original, which is 14.5. And we're going to add the error here. And here the original, and we'll subtract the error. Okay. So this right here will give us 14.55. And this right here will give us 14.45. So the error interval for V is as follows. So 14.45 over here and 14.55 right here. Okay. I hope this was clear. Okay, now let's move on to some exercises. As per usual with exercises, you should pause the video and try to solve it on your own, and then check your answer. Let's take a look here. So question 1, number y is rounded to the nearest 3 decimal places to give 6.742. Find the upper bound of y. Okay, so So firstly, I'm going to go ahead and write the number down. 6.742. And we know that this number was rounded to 3 decimal places. So let's go ahead and look for the third decimal place. So 1, the first decimal place, second decimal, and this is the third right here. So we replace the third decimal with a 1, and everything else becomes 0. So 0.001, okay? Now we divide this by 2 to find the error. And we get that the error is basically 0.00. Like I said, replace the 1 by a 0 and a 5, okay? So this right here, this is my error. So let's find the upper bound. So the upper bound is equal to 6.742 plus 0.0005. You can put that on the calculator if it makes you feel more comfortable, or just write down the answer right there. Okay, so now part B. Find the lower bound of y. So the lower bound, it's the original number, 6.742, 2, and instead now we're gonna subtract 0.005, and this gives you 6.7415. This is the answer. Okay, and this is the answer for the upper bound. Okay, part C, state the error interval of y. So like I've said, so y is basically greater than or equal to the lower bound, which is 6.7415, and it's less than the upper bounds, 6.7425. Okay, that's it. This is this right here. This is the answer. Moving on to the next question. Given that p is equal to 23, correct to the nearest whole number, and q is 9.6, correct to two significant figures, and r is 3.7, correct to one decimal place, find the upper bound of p. Okay, so let's find the upper bound of p. So I'm going to write p down. So p is equal to 23. Now, we know that this was rounded to the nearest whole number. So where is the nearest whole number? It's this 3 right here. Okay, this is the first whole number. So this becomes a 1, and everything else becomes 0, but there is no need to put a 0 on the left. So it's just 1. And we divide that by 2, and this gives us 0.5. Just wait. Okay, so 1 divided by 2 is half, obviously. So now the upper bound will be the original, which is 23 plus 0.5, and this gives us 23.5. So this is the answer for A. As for B, they want the lower bound of Q. Now, Q is equal to 9.6, and this is a rounding to two significant figures. So this is the first significant, this is the second. We replace the second by a 1 and everything else by a 0. And don't forget your point. So 0.1, and we divide that by 2 to find the error, which is 0.05. This right here is the error. So the lower bound will be the original 9.6 minus 0.05, and we get 9.55. Okay, I'm gonna solve C on the right hand side. Okay, so they want the error interval of R. So like we've said before, when we want to find the error interval, we need to find the lower and the upper bound. So R is equal to 3.7, and this is correct to one decimal place. Okay, so where is the first decimal place? It's right here. We replace it by a 1, and everything else becomes a 0. So this is 0.1. I will rewrite this. So 0.1, okay? And divide this by 2. It gives us 0.05. And now I'm going to find the upper bound and the lower bound as well. So basically 3.7 plus 0.05. We get 3.75. And 3.7 minus 0.05, and we get 3.65. So the error interval of R is basically greater than or equal to 3.65, and it's less than 3.75. This is the final answer. Okay, let's take a look at this question. So given that m is equal to 2.8 to the nearest one decimal place, n is equal to 3,400 to the nearest 100, and O is 15.7 to the nearest three significant figures, find the upper bound of m. Okay, so A. Now the upper bound of m, we're going to write m down firstly. M is equal to 2.8, and this is rounded to the nearest one decimal place. So I'm going to locate the first decimal place. It's right here. and replace that by a 1, and everything else turns to zeros, so 0.1, and we'll divide this by 2, and we get 0.05. This right here is my error. Okay. So in order to find the upper bound, it's basically 2.8 plus 0.05, and we get 2.85. Now let's take a look at part B. Now, the lower bound of n. So n is right here. I'm going to write it down. N is equal to 3,400. And it's rounded to the nearest 100. So the error, the unit of round is 100, basically. We can just directly put that and divide this by 2. It gives us 50. Okay, so this right here is your error. And so they're asking for the lower bound. So lower bound is equal to 3,400 minus 50. And this yields 3,350. Okay, this is the lower bound. Okay, finally, part C. The error interval of O. So let's write O down. It's 15.7. And this is to the nearest 3 significant figures. Okay, I'm gonna go down a little bit. Okay, so we're gonna count to find the third significant figure. This is the first, this is the second, and this is the third. So we're gonna replace the third one by a 1 and turn everything else into zeros. And like I've said, 0.1. You don't need to put another 0 here. It would be meaningless. Now, this is the unit of round. Divide this by 2. We get 0.05, and this right here is my error. Okay. Now I want my error interval. The error interval will be basically between the upper bound and the lower bound. So let's find those, upper bound and lower bound. The upper bound is going to be 15.7 plus 0.05, which gives us 15.75. And the lower bound is 15.7 minus 0.05, which gives us 15.65. And so my error interval for O is basically greater than or equal to 15.65, and it's less than 15.75. Okay, question 4. A number z is rounded to the nearest 2 decimal places to give 5.39. Find the error interval of z. Okay, so we want the error interval again. So now we'll write the number down, 5.39. We know this was rounded to 2 decimal places. So let's find the second decimal place. This is the first. This is the second. We'll replace this by a 1 and everything else by a 0. And now we're going to divide this by 2 to find the error. The error will be 0.005. This right here is the error. Now, to find the error interval, or to write it, we need the upper bound and the lower bound. So I'm going to go ahead and find those. So 5.39 plus 0.005, we get 5.395. And the lower bound is 5.39 minus 0.005. And we get 5.385. Okay, so this is lower bound, and the error interval will be z is basically between 5.385 and 5.395. Okay, this is the answer. That's it for this. Now, by the way, it's really important to show all your working, okay? All the working is important to show. Moving on. So now we will talk about examples with real life measures where it's not just numbers, it's actual measurements. Okay, so let's see. The height of a building is recorded as 50 meters to the nearest meter. Determine the upper bound of the height, and B wants you to determine the lower bound of the height. Now, when it comes to the upper bound, so we know that the height of the building is 50 meters, okay? And this was to the nearest meter. The nearest meter, and we're measuring meters right here, so it's basically the nearest whole number, really, okay? So when you have the exact same unit, just like meter right here and meter right here, you can just go ahead and basically just write 1, right? Which is basically replacing the nearest whole number, okay? So it's just 1, and we're going to divide this by 2, and we get 0.5. Okay, and this is the error. Okay, so now for part A, to find the upper bound of the height, it's basically 50 plus 0.5, and this gives us 50.5, okay? And for part B, the lower bound, it's going to be 50 minus the error, so minus 0.5, we get 49.5, okay? Okay, so a car travels a distance of 100 kilometers measured to the nearest kilometer. Calculate the upper bound of the distance. Okay, so basically it traveled 100 kilometers to the nearest 1 kilometer. So the unit of round here is again 1. It's just the same unit, okay? So we'll divide this by 2 to get our error, which is 0.5. So this is the error. And now the upper bound is 100 plus 0.5, which gives us 100.5. As for part B, they want the lower bound. It's going to be 100 minus 0.5, and that gives us 99.5. Okay, let's take a look here. A length of wood is measured as 12 centimeters. Why is there spacing? Okay, to the nearest centimeter. What is the lower bound of the length? Okay, there is an extra bit of space here accidentally. Anyways, so now the length of the wood is 12 centimeter, okay? To the nearest centimeter, so our unit of round is just 1, and divide this by 2, we get 0.5, so this is my error. And I'm going to go ahead and find the lower bound, so lower bound is equal to 12 minus 0.5 gives us 11.5, and the upper bound is 12 plus 0.5, which gives us 12.5. Okay, so this is the upper and this is the lower bound. Okay, a student measures the mass of a bag of sugar as 1.5 kilograms to the nearest 0.1 kilogram. Find the lower bound of the mass. So basically here, so we know that the weight, that's part A, so we know the weight is 1.5 kilograms. And the unit of round is actually 0.1 kilograms. So it's the same thing, but it's 0.1 this time, okay? So we're just going to divide 0.1 by 2 and get 0.05, okay? Now the lower bound is basically 1.5 minus 0.05, which is 1.45. And the upper bound will be 1.5 plus 0.05. We get 1.55. Okay, so this is the upper bound and this is the lower bound. Okay, question 5. A piece of wood is cut to a length of 3.2 meters to the nearest 0.01 meters. Okay. Find the error interval for the length of the piece of wood. Okay, so 3.2 meters, and the unit of round is 0.01 meters. So we're going to divide that by 2, and we get 0.005. Okay. So now we want the error interval. Okay. So in order to find that, we would first need to find the lower bound and the upper bound. So the lower bound is basically 3.2 minus the error. This is the error, which is 0.005. And we get 3.195. Okay. And the upper bound is 3.2 plus 0.005. And we get 3.205. Okay. So the error interval is basically the length, which is basically between 3.195 and 3.205. Okay. Question 6. The time it took a runner to run around the track was recorded as 30 minutes to the nearest minute. Find the shortest possible time the runner took. So he took 30 minutes to the nearest minute. So the unit of round is 1. And dividing this by 2, we get 0.5. This is the error, okay? Now, here's the thing. We want the shortest possible time, okay? The shortest possible time is definitely not the upper bound. It would be the lower bound, okay? We want the lower answer. So, to find the lower bound, we're going to write 30 minus the error. And so we get 29.5 minutes, okay? So this is the shortest possible time, or the minimum time, which is basically the lower bound. Okay, now let's take a look at some exercises. Okay, so a weight is recorded as 4.3 kilograms to the nearest 0.1 kilogram. Find the upper bound. Okay. As usual, you should pause the video and solve those on your own, then check your answer. So the unit of round is actually 0.1. Dividing that by 2 gives us 0.05. This is my error. So now the upper bound is 4.3 plus 0.05. So 4.35. Okay. Now the lower bound is going to be 4.3 minus the error, which is 0.05. So it's going to be 4.25. Part C is asking us to state the error interval of the weight. So the weight is basically between, it's less than 4.35 and it's greater than or equal to 4.25. Okay. A volume of water is measured as 12 liters to the nearest liter. State the error interval of the volume. So we have 12 liters basically, and this is to the nearest liter, to the nearest 1 liter. So the unit of round is 1. Divided by 2, it's 0.5, and this right here is my error. Now the question is asking for the error interval. To find that, we firstly find the upper bound and the lower bound, and then write the error interval. The upper bound is going to be 12 plus 0.5. That gives us 12.5. And the lower bound is 12 minus 0.5, and this gives us 11.5. Now the error interval, so the volume is greater than or equal to 11.5 and is less than 12.5. This is my error interval. Now, the length of a table is measured as 4 meters to the nearest meter. Find the error interval for the length. So now the length is 4 meters to the nearest meter, so the nearest 1 meter, okay? So the unit of round is again 1. Dividing this by 2 gives us 0.5, okay? And this is my error. So 4, so in order to find the error interval, we will find the upper bound and the lower bound. The upper bound is going to be 4 plus 0.5, which is 4.5. And the lower bound is going to be 4 minus 0.5, which is 3.5. So the error interval for the length is greater than or equal to the lower bound, which is 3.5, and is less than the upper bound, which is 4.5. Okay, final exercise. The height of a student is measured as 1.65 meters to the nearest centimeter. Find the upper bound for the height of the student in meters. Okay, so his height is 1.65 meters, okay, but this is rounded to the nearest centimeter, okay? So we can't just write 1 here and divide this by 2. It would be wrong because they're not the same unit, okay? This is meter, this is centimeter. Now you have two options: either make this into meters, into centimeters, or change the centimeters into meters. Now we do know that the final answer needs to be given in meters, so it would be easier for me to just grab the centimeter and change it to a meter. Now we know that the centimeter to meter conversion ratio is that 1 meter is 100 centimeters, okay? So to convert, we're going to divide this by 100, and we get 0.01 meters, okay? So now it's basically 1.65 meters rounded to the nearest 0.01 meter, okay? So we can go ahead and this right here, this is the unit of round. We'll divide it by 2 and we get 0.005, okay? So this is my error. So now they want the upper bound. So the upper bound is basically 1.65 plus my error. And we get 1.655, okay? So that's it. So, of course, this is in meters. So when the unit is not the same, you need to change either one of them to the other. Okay, I hope this is clear. This should make you feel confident in finding upper bounds and lower bounds, okay, for all kinds of measurements and the error interval. We'll get to more complicated upper and lower bound applications in another video. Okay, thank you for watching.